All right, welcome to this lesson. We're going to be talking about compound probability, and I'm going to be using the Study Island lesson page. So if you want to go to the Study Island lesson page, you can go there and you can see what I'm talking about. This will be some great examples. I also work out some of the problems on Study Island and then do some of my own. All right. Probability, first off, is as it says right here, it says probability is presented as the ratio of the number of ways an event can occur relative to the number of possible outcomes. Basically, how many ways can what you're looking for happen over top of how many total ways can something happen. For example number one, if you roll a die, what's the probability of rolling a 4? Well, if we roll a die, how many options are there? Well, you've got an option of 1, 2, 3, 4, 5, or 6. That's a total of 6 possibilities. However, we wanted to know how many of those possibilities are 4. Well, it's just 1 4 on a 6-sided die, so that is 1 out of the 6 possibilities. Example 2. If you roll a die, what's the probability of rolling a number less than 4? Well, less than 4, still, we're looking at 1 through 6 is our total number of possibilities, but how many of those numbers are less than 4? Well, 4 cuts off right here, and everything less than that is 1, 2, or 3, as it says up top here. That is 3 possibilities out of our 6 total options, and we can reduce our fraction down to 1/2. Next, if you pick from a bag that contains 5 blue marbles, 2 green marbles, 3 red marbles, what's the probability of picking a red marble? Once again, how many total possible options are there? Well, given that there's 5 blue, 2 green, and 3 red, that's a total of 10 marbles that are inside the bag. And out of all those marbles, only 3 of them are red. That's why 3 out of 10 is our probability. Now, that's basic probability, and that's not compound probability yet. Compound probability is when I take this and combine it with another event. All right, so for any 2 events, A and B, the probability of A and B is such that we multiply. And the key thing that we're talking about here is that we are multiplying the 2. All right, and this is actually going to talk about independent and dependent events. All right. So as we're looking at this, A and B, and right there is a key word. It's going to tell us to multiply those 2 events. All right, and tells us to multiply. That's one of our key words. And means multiply. Our other key word that we'll look at is or, which means addition. All right, so the probability of A and B is the probability of A times the probability of B, given that A has occurred. All right. So as we're looking at that, we're looking at the 2 options there for probability events. Let's look at an example to really walk this through. A bag of chips contains 2 blue chips and 4 red chips. Thomas draws 2 chips from the bag with replacement. What is the probability of drawing a blue chip on the first draw and a blue chip on the second draw? So we are looking at the probability of blue and the probability of blue. And this with replacement means that the number of chips inside the bag didn't change from the first to the second time. We'll talk about what that looks like when it does. All right, so these are 2 independent events. They can happen and one will not impact the other. So again, when we're looking at and, we're multiplying these 2 events. So what's the probability of getting a blue chip? Well, that is 2 blue chips out of a total of 6. So that is 2 out of 6. For my probability of getting a blue. And we multiply that by the probability of getting another blue, which again, it's going to be 2 out of 6 because if I did get a blue the first time, I put it back. So when I go to pull again the second time, there's still 2 blue chips in there and there's still a total of 6 chips. I can multiply these 2 together. 2 times 2 is 4, 6 times 6 is 36, and then that can be reduced down to 1/9. You could have reduced the fractions earlier if you wanted to. All right, I could have made this 1/3, made this 1/3, and then gone directly to 1/9 when I multiplied them. That's actually my personal preference. All right, and that's what we see down here. That's what they're showing. All right, let's take a look at the next example. Example number 2. This time, a bag of chips containing 2 blue chips and 4 red chips. All right, it exists, and Tom draws 2 chips from the bag, this time without replacement. What is the probability of drawing a blue chip on the first draw and a blue chip on the second draw? Well, as we saw before, all right, our probability of blue is what we're starting out with. Probability, I'm going to abbreviate blue with a B. And probability of blue again. All right, but this time the probability of blue is 2/6 as we saw, and tells me to multiply The probability of blue the second time now is only 1/5. Take a look right there. It's only 1/5. That's because if I had the blue chips, and I'll mark this out. Let me actually draw a little diagram for you. If I had a bag, there's a blue chip, there's a blue chip, and I've got 4 red chips. We can see that there's 6 total chips in that bag. 2 of them are blue. And if I take one of those blues out on the first draw, well, now what's my probability of getting a blue? My probability is now only 1 blue out of 5 total chips left in the bag because I did not replace that first one. This is what we call a dependent event. The probability of the second event depends on what happened the first time. If I pulled a blue as we wanted the first time, then the probability of blue changes. And we always assume in probability that it happened. When I say the probability of a blue, I'm assuming I did pull a blue. All right, and then I look at what will be left over and the chances of me getting a blue that next time. All right, let's take a look at different compound events. All right, what if I'm rolling 2 die? All right, and in this case, I'm rolling the 2 dice and I'm asking you for the sum of 7. All right, what's the probability of getting the sum of 7? In this situation, and I've gone through some of these in my practice test, they're asking me to do something with the results of the die. You can still do this using the keywords of and, which tells you to multiply, and or. However, you're going to have to think through all the possibilities. So I'm going to show this route first, but then I'm going to show my recommended route. If you'd like to fast forward the video, go for it. As I look at this one, the probability of 2 dice and sum of 7, I have to think of what all those options are. That is the probability of getting a 1 and a 6. All right? But that's also the probability of rolling a 6 and a 1. It's also the probability of what if I got a 5 and a 2, or a 2 and a 5. And then lastly, what if I rolled a 4 and a 3, or a 3 and a 4? Because you got to remember, those are 2 different options. When I roll a 4 and a 3, it's different from a 3 and a 4, all right, because it's what you get on the first die versus what you get on the second one. Well, it's all of these, and it's one and the other, all right, or the next one. So it's either 1 and 6. Probability of rolling a 1 is 1 out of 6 options, and getting a 6 is another 1 out of 6 options, giving me 1 out of 36 for the probability of just rolling a 1 and a 6. I could get that, or I could get this one. All right, and I can get the probability of all of these. Notice I'm multiplying in each one individually because in each one it's asking me for one and the other. All right, and that's why I'm multiplying here. All right, so 2, probability of 2 is 1/6, and probability of 5. So it's 1 out of 36 options. All right, probability of 3 is 1 out of 6 options, and probability of rolling a 4 is 1 out of 6 options. Give me 1 out of 36, and once again, 1/6 out of 1/6. So all of these possibilities are 1 out of the 36 total combinations we can get from rolling a die. Granted that I could get this one, or 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 this one, means that I'm going to take all of these, keyword or, and I'm going to add them all up. Well, that's 1, 2, 3, 4, 5, 6. That's 6 out of our 36 options. All right, that can reduce down to 1/6 altogether. So that's the way to do it with fractions, but that's a lot of work. Whenever they ask you to do 2 events and then do something with the results, in this case we're rolling 2 die, and then we're adding the results together. Whenever that's the case, it's often easier to just draw a diagram instead of going through all this work. So let me show you how I draw that diagram. If I were to do a diagram for this exact same thing, I would draw a probability rectangle given that I have 2 events, because a rectangle has 2 dimensions, all right, our base and height. And I put each event on one of my dimensions. And I put all the possibilities for that event along that dimension. So up top I put 1 through 6, because when I roll 1 die, I have options of 1 through 6. Same going down the side. I'll put this down this way. Now, when I combine these, this is going to give me a nice table, all right? And I get all these possibilities. And if you ask yourself how many total outcomes there are, well, this is a 6 by 6 rectangle, and 6 times 6 is 36. All right, and that's where we have a total of 36 combinations. How many of these will add up to get 7? Well, 1 plus 6 is 7. All right, 2 plus 5 is 7, 4 plus 3, 3 plus 4, 2 plus 5, and 1 plus 6. So it's 1, 2, 3, 4, 5, 6 of our possibilities add up to 7, giving me 1/6. Now notice, that's the exact same thing we saw here. Saw that each one of these combinations was just 1 out of the 36 squares. All right, just 1 out of the 36 squares, and there were 6 of them that added up to that. In this case, the diagram was much quicker. It's not always the quickest, all right, but sometimes it is. Take a look at this example. We're going to flip a coin and roll a die. What's the probability of getting a heads and an even number? I'm going to show you both routes again, a diagram and the other route, using our keywords and and or and multiplying and adding fractions. So and again is multiply, or is add. All right, and if I look at this, probability of heads and an even number. Well, that's a probability of getting a heads and the probability of rolling an even on our two events. Well, probability of heads is 1/2, and getting an even number is 3 out of the 6 options. In other words, 1/2. And if I multiply these two together, 1 times 1 is 1, 2 times 2 is 4. I'm done. I get my result of 1/4. All right, that's quick and easy. All right, I could also do this with a diagram though. Given that it's 2 events, I do a probability rectangle because rectangles have 2 dimensions. And again, I can do my one event across the top, giving all the possible combinations and outcomes of that one event. Down the other side, I will give my other event, in this case a coin, which only has 2 possibilities of heads or tails, which is why I only give 2 dimensions down the side there. And I want to look at all the ones that are heads and even. Well, heads and even is right here, and right here. That is 3 spots out of our total of 6 by 2, 12. And 3 12ths reduces down to 1/4. We get the same result either way. So in this case, I think going fractions is easier because they're not asking me to do anything with the results. They're just asking the probability of one event and the probability of another event. What if we were to change this to or? What if I asked you probability of heads and even, which we just found, or tails and odd? Well, if I do that, I've got heads and even. So as we said, probability of heads is 1/2, and probability even is 1/2, giving us 1/4 or altogether. Or says to add that result to the other possibility here, all right, where I have tails, all right, which is 1/2, and odd, which is 1/2, which gives me 1/4 altogether. And 1/4 plus 1/4 is going to give me 2/4. In other words, 1/2 of the time you should get tails and even, heads and even, or tails and odd. Let's look at our diagram. Heads and even we saw were these ones right here, or tails and odd are these ones right here. And notice if I count them up, I get 6 out of the 12 possibilities, which is again 1/2. With drawing a diagram, you can see it right away, and it just takes a little longer to draw that diagram. With using your and or and multiplying, sometimes you can get there quicker, but it can be a little bit more complex if you're having a tough time thinking through how that all works out. Let's take a look at one more example. All right, if we're flipping 3 coins, what's the probability of getting at least 2 heads? All right, in this case here, probability of at least 2 heads, if we're going to use our keywords of and or, we have to think through all the possibilities of getting at least 2 heads. If you can do that, you can use and or. If you can't do that, you need to draw a diagram. Getting at least 2 heads means I'm looking for the probability of heads, tails. All right. The probability of heads, tails, heads. The probability of tails, heads, and the one that would be most likely missed, the probability of heads, because that's at least 2 heads. It's 3 heads, which means it's at least 2. These are our options that are available to us. And if I want to get this, I can look at the individual probability of each. Heads and tails. Well, probability of getting heads is 1/2, and another heads is 1/2, and a tails is 1/2, giving me 1 out of the, careful, 2 times 2 is 4, times 2 is 8. 1 out of the 8 possibilities. It's not 6 there. All right, it's not adding the 2's, it's multiplying them. All right, and I can see I'm going to actually get the same exact thing here because this is another 1 out of our 8 possibilities. And that's going to be the same all the way down here. All right? And if I'm going one or the other, that means I can get the first one or the second or the third. So I'm going to add all of these up. And if I add up all of these, that gives me a total of 4 out of our 8 possibilities. And 4 out of the 8 possibilities is 1/2 altogether. That's using fractions. Again, that can be challenging if you're thinking through all those possibilities. But what if I were to draw a diagram? Given that there's 3 events, I cannot use a probability rectangle. I must use a tree. A tree is when I take each event and give it its own column. And then we have an outcome column. So in this case here, coin 1, I have the chance of getting heads or tails, and I spread that out intentionally because in coin 2, I have to write both of my options, heads and tails, for both of the previous options in the tree. And that's where we get the tree diagram from because it's going to branch out. Coin 3, then I have to repeat each of their options for each of the branches before it. And this is where drawing a tree diagram can be very tedious, but again, even though it's tedious and longer, it's worth it if you're getting the problem correct. And now, in order to get my outcomes, which come from each of these final branches, I trace my tree diagram from the beginning to that path. So I'm going to switch colors here. So if I go from heads to heads to heads, that gives me an outcome of heads, heads, heads. All right, that's one of the ones that was at least 2 heads. What if I went heads to tails? Another one that was at least 2 heads. And if I go heads to tails to heads, I see I get a third of my options with at least 2 heads. The next one, however, if I go heads to tails, all right, that does not give me one of the ones that I'm looking for there. All right, because it doesn't have at least 2 heads. So far I've got 1, 2, 3 of the ones that I was looking for. And then across the bottom here, tails to heads to heads. And I could see that any of the options after that are not going to give me at least 2 heads. But I can count them, and I see I have 1, 2, 3, 4, 5, 6, 7, 8. 8 total possibilities where 4 of them were what I was looking for, and therefore it reduces down to 1/2. So that would be using a diagram for this one.